Welcome to the public AI Café today. Our speaker is Farah Mehboob, the CEO of Insight Analytics company called Validate. And her talk is Learning Between the Lines, Transfer Learning Approach for Time Series Data. My name is Farah Mehboob. I'm the moderator and organizer of this cafe. And please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for Media project opinion. And what's the cafe about? As always, it is about taking the audience and the speakers and connect them, connect the participants to share knowledge and experiences and meet stakeholders from various areas of AI research and application. So again, welcome who's joining us today in the cafe. As you know, it's interactive, so we really look forward for your questions. Please send them to us. There's a control panel, hopefully on your screen on the right side, where you see questions and chat. And there you can write us your questions. For example, if you want to know something of the speaker or you want something to know about the cafe, please send it to us. And now the most important, our speaker, I will introduce her now. Hi, Farah.
Hi everyone. Hi, Carmen. Thank you for having me. Very excited about this talk. So AI Cafe has really launched this great initiative where they're bringing in academia and industry people to understand more and more AI. And what really excites me, can I change the slide?
You cannot yet open it because I will still introduce you. Then you can start your talk and your slides. I'm still the moderator because we have to wait. Some people are still coming, so that's why I'm introducing you and then you start. So Farah Mehboob is a CEO of Insight Analytics company Validate. She has extensive knowledge on using time series data sets to optimize tech solutions. Farah has advised multiple tech startups on operational improvement, recruitment, optimization, and supply chain using deep learning methods for time series analysis. Farah teaches artificial intelligence and business intelligence as visiting faculty of computer science at SMCS IDA in Karachi, Pakistan. Her interest lies in developing relevant AI skills to reduce industry-academia gap. She is the founding member of Aspire, an entrepreneurship support network in Pakistan. Great. This sounds super interesting. So we are very glad to have you here. And now I give you the moderator role. Now, one moment. You will now be the moderator. Yes. And you can slowly open your presentation and the stage is for you.
Thank you. So my screen is visible?
Yes. Perfect.
Okay. Welcome everyone. Thank you, Carmen, for such an amazing introduction. I'm very excited to be here. I'm very excited and grateful for the attendees to be here. This is a great learning experience that we can interact and we can have live questions, and feel free to ask anything in between or in the end. the motivation to be here is to see how many things are out there in research or in application that can be used to mimic how humans behave, to do better data processing or data analysis of predictions. And one of the very exciting things that has happened, it's a recent update, is that time series analysis can be done by deep learning models. So I'll go into a bit of history of why is it exciting and groundbreaking, but that is we'll have to wait for a while to get there. Before that, I'll just set up the stage and I'll show what we're going to explore today. My screen just went off. Am I still sharing?
Yes, you're showing now, your PowerPoint is basically now showing topics, and then another window is over it. You have now.
So is it all my presentation? If you confirm, I can continue.
It is your presentation, but you have a window over it, like Pinnet, Edge, Word, Excel, yeah. PowerPoint.
So I just put it down here. And try again. And now it's just my screen, my presentation.
No, it's still this other window on top. I will now take away the moderator role of you and we try again. One moment. We will take it away because something popped up on your. I'm going back. So please everybody stay with us. We will. So now it's mine. And now I give it back to you. So I make you the moderator, yes? Let's try again, Farah.
So I'm trying to share my screen. Is it shared? Shared? Okay. So awesome. So what we're going to look at today, is what is time series data, what is transfer learning, and what is the magic that NBIT's model perform to induce transfer learning in time series data. So time series data is actually any data which is an observation over time, and it can be real-time data.
We don't see the PowerPoint. We don't see it.
Sharing. So what's visible on the screen, if I may ask?
Only the two of us.
Show screen.
So we are trying.
Is my screen visible?
Not yet. No.
Karen, can I request you to please let's do our sharing of moderator exchange one more time. Something.
Yes.
Yeah. Thank you very much.
So now you see my presentation now, yeah?
Yeah.
Do you see mine?
Yes, I see. What is the AI Café?
Good now. And now we go back to yours. So make you the moderator.
Am I the moderator? I don't see any change. Yeah. Show my screen, and I share my screen.
Good, perfect.
And thank you for your patience. That really was a bit of to and fro. So time series. What is so exciting about time series? Well, these days, when more and more people want to work on data, they want to work on real-time data, they want to work on continuous data, and they want to work on exciting data, such as e-commerce data, which is really popular. Most of this data is time series data. So understanding what is time series data and understanding how can we really analyze and predict time series data using latest technology is something really important in academia. We have our own competitions for it, but it's also important for deploying in industry. So let's look at what time series data is. It's a collection of observations obtained through repeated measurements over time. So clearly there are two features of time series. One is what you can see on this screen as an upward trend. So the fact that it is going up with some interval after some interval, that's called trend in time series. And these peaks and this peaking data in sinusoidal form after a certain interval, that's seasonality. So seasonality and trend are two things that are features of time series data, and we just try to make any time series more predictable by trying to understand how to cater, treat, or predict seasonality and trend. So what is transfer learning? Like, everything in deep learning model has been inspired mostly from the way human brain works. So it's either human memory or human learning system or human ways of analysis, domain modeling. So what we call as human perception, if we were to code it, that would be transfer learning. If I were a good chess player and I had practiced chess for a couple of hours and a couple of years, couple of hours, and been an expert in it, I can use my skills of planning ahead, which I've learned as a chess player, in doing any other strategical work. And that's very common for human beings. In fact, most of the time we are learning in one environment, and then that environment is gone and our skill stays with us and we use it to do other things. That's what makes us experts. So this transfer learning concept has been very recently applied on time series to predict a lot more than what the data was trained on. This is a seminal paper by Joshua Benjo and his team at Element AI, NBEAT's Neural Basis Expansion Analysis for Interpretable Time Series Forecasting. So this model has actually really changed a lot of trends in time series analysis. We've been seeing deep learning for about 10 years now, and wherever deep learning is deployed, the results have generated more accuracy as compared to the traditional methods in stats. However, until 2020, until this paper was launched, the statistical methods for time series analysis performed better than the deep learning model. And it was thought that maybe time series analysis cannot be optimized using deep learning models. However, NBEATS, what it did was, if you can see this last three lines that are orange in the orange square, it increased in one of the competitions for time series analysis. It was M4 competition. Joshua's and his team's NBEATS model improved the accuracy by 11% over statistical benchmark and by 3% over the last year's whatever statistical model was used on the same competition. So that was great. That was accuracy achieved by a great distance, and that is why NBEATS got very popular ever since then for time series analysis. So let's look at this magical NBEATS model from the inside first. NBEATS model also, this M4 dataset, this M4 computation has about 10,000 time series to predict from, coming from finance, economics, and demography, and other such genres. So that's a really big data set to work on. We'll see the results in a bit, but first we see what is in NBEATS. And so the inside of NBEATS looks something like this. This is actually a picture from the paper where it was first proposed. So don't be overwhelmed. It's really easy to understand, and we're going to understand step by step, and we'll see how it's all put together, and then we'll try to identify where exactly transfer learning takes place. So every NBEATS model
We cannot hear you anymore. Farah, did you disconnect? Farah? I hope she comes back. I think, so please everybody be patient. I hope Farah comes back. Now her video is gone. We don't hear her. Farah?
Hi, I'm back.
Cool. We see your power.
Yeah, I just shut off my webcam so that I just don't bounce off again.
Okay.
Right. So this is what NBITS looks like, and this is used for transfer learning in time series. So if you look at this blue block, this is the unit of NBITS model, and it has 4 fully connected layers. Those fully connected layers actually split into 2 outputs, and there is some mathematical transformation which actually transform these 2 outputs into what we call backcast and forecast. So what is forecast and backcast in NBITS? This is really interesting. Yeah. So after this basic block is created, it is created multiple times and then put one on top of the other, and we call that stack. So it's not a single block, but this fully connected layer of four neural network layer of four hidden layers, and then 2 output layers. That block actually is piled one upon another to make one stack. And then there's not a single stack, but in NBITS model, we have a lot of stacks. So all those stacks are collected together to make the NBITS model. And the output of all these stacks is added to get the final forecast. So why is it so different than a normal statistical model? Because it gives a very interesting feature to train on a multi-horizon prediction, which actually means that you can decide whether you want to predict for the next 2 days or for the next 2 hours or for the next 2 months. And that is very powerful for practitioners to get this independence of forecasting for a certain horizon. Also, the look back period, which is a multiple of horizon, gives another feature to NBITS model of not really carrying the whole data in the background, but you can considering this model, we have n equal to 3, so we just need to look back 3 chunks of a forecast period, and that is going to be our input for the model. So really, now let's look at a little bit more of what happens inside the block. This example is from the benchmark paper. The benchmark paper, what Joshua and team did, they actually ran the NBITS model on M4 computation, M3 computation, and multiple data sets, and showed that every data set performed better on NBITS than on other models. So there was one data set, electricity data set, which had and this parameter configuration comes essentially from electricity data set. So the data actually is poised to predict electricity for 1 day or 24 hours. It's an hourly data. So they select 72 observations, which actually means that they say we're going to process 3 days of data from the past to predict 1 day of data in the future. And for doing that, the parameters have been taken right exactly from the original model, and they're all fully connected. So you can see where it is dense 1, we have observations multiplied by 512, and then 512 into 512 because it's fully connected, and this goes on. Over here, there's a split of results into 2 outputs. So on this layer, we have a theta parameter B and theta parameter F, and this again goes into this last layer where there's a transformation taking place. What we get in the end is a backcast, which is 1 by 72, and a forecast, which is 1 by 24. And this backcast and forecast becomes the input to the next block and the next block and the next block until there's an output of the stack, which becomes the input to the next stack. So what really happens between these layers is that all the optimization is not done in one layer. The data is input at the first level, and when the data is input, the model tries to learn some part of the data, and whatever has been optimally approximated, that is called this x bar slash L. So this is the part of the model which is approximated optimally. From the original data, this part is subtracted, and after subtracting this, the rest, the unoptimized part is sent to the second block. So every part of the block is actually optimizing some aspect, and whatever it is not doing, it is sending it down to the other block and the other block. So in the end, every result from every block is added to get the final result, and that is the output of the stack. And that stack actually gives the output to be repeated. The same whole process is repeated for m number of stacks, and all the outputs are finally added. Let's look at the code and how it works. So what you see on your screen is a Darts deployment of NBITS model. Darts is a very nice library to practice understanding NBITS and also to running NBITS. NBITS is fairly new, so you can also start to code it from the scratch. But the nice thing about Darts model is that it has configured NBITS exactly on the NBITS paper. So you don't have to give too many parameters. It's already settled. The layers are there. All the configuration is right, the same as the paper, and you can still run it. So there's a time series data on the right side, and it has an upward trend. This is a data called air train, and we create an NBIT model, and we give it all the parameters the same as in the paper. And then we fit the air train model, which actually means to predict these 3 years of data, we are training the model on this data. So we're training the model on this data to understand trend and seasonality and to predict what happens in the next 3 years. So that's what fitting is doing. Prediction is made, and you can see the blue line, right? So this is the kind of prediction, which was not bad, which is really good. So the data was predicted. The error that we get on this model is the median of SMAPE is 24.331. Now, I just showed you M4 data. This is one time series. M4 data is actually, it comprises of 10,000 time series. Excuse me. So, and those 10,000 time series have different seasonalities and different trends. This is a snapshot of some time series from yearly seasonality, quarterly seasonality, monthly. I should get some water. Yeah. So you can look at the variety of data on the right side, the different seasons, the different trends. And the only change we make in this code is that instead of fitting this old data, we fit this new data over here. So we're saying train the model, just the same model, but for training, use the M4 competitions dataset. And what are we going to predict? We're actually going to predict the same 3 years that was predicted here. So lo and behold, look at what happens. When we predict the same 3 years, what we get is an error which is 2 points, 2 calibrations less than our previous error. So the same series predicted and generated error which had 24 whole number and 0.331. And M4 competition trained data generated a prediction with a lower error. And that is what transfer learning is. The model itself cannot predict itself as well as another model if there is variety of data given to it. And this is a turning point in time series prediction analysis that you can actually, the utility of this is that you can actually take a lot of data if it is available, train your model, and then work on a scarcely available data and still predict accurately. This is really good for sales. This is really good for customer profiling, but also in healthcare. When you have to predict a disease, you'd have similar kind of data, but not data just for that case, and you can still make good predictions. So now, really, what did just really happen was that this block was doing one part of learning, and this stack was doing another part of learning. This block, when we look at the details and the maths and how it works, it was learning the series, the internal features of the series, which was helping in predict the series. But when we were creating stacks upon stacks, that actually started to train the model to learn about longer dependencies across all time series. And that learning was much richer when we had given 100,000 time series of M4 data set. So this aspect of learning was improved by giving more data, showing more variety of time series data, and which is why the prediction improved with M4 data set. So well, these are the references I have used, including the Colab for the code if you want to run it. And there's so many there's so many deployments of this that I'm very excited to see how you plan to use it, or what do you think can be a use of this time series. And I'm open to any question and answers to clarify anything or answer anything outside of M4 competition data set on this.
Yes, thank you. Thank you, Farah. It was very interesting presentation. Could you give us an example what you think you can use it for? I mean, you said medicine or sales, but more concretely, like what concrete example, what could be an application?
Yes, actually, one of the very exciting applications of NVID's model is to learn on how e-commerce data will perform. So because there's huge demand and supply prediction going on, and that really directly affects the warehousing, and a lot of money can be saved if we can predict the right demand on our online sales, on our e-commerce websites all over the world. And that is where, no matter where you're purchasing from, if the data is diverse enough for training, then we can use the good trained model for predicting new product sales, new product demand of the same category. So you don't need to wait to collect data for it. You can still predict accurately.
Yes, thank you. And please, all the participants in this cafe, please send us questions. I keep asking, but it would be nice you just send us your questions. So, and now a little bit to your company. Your company called is Validé, and I know it's located in Karachi in Pakistan. Yeah, it's great. Who are your main customers? Where are most of your customers located?
Yeah, so most of my customers are from either Dubai or Pakistan itself, but they are the people who are connected with the whole world. So my customer of my customers are very global, and we do social listening, and we do insight analytics for social media content. So we have used very innovative ways to predict the next trend on the social media platforms, and that has really helped our clients a lot in again demand forecasting.
Great. Do you have also customers in the European market?
Well, actually, we are still learning to comply to the legal practices. We're working very closely with For Humanity to have a well-versed understanding of our information exchange policies. We don't have a lot of customers right now, but hopefully we'll have soon.
Great. Yes, here's a question from Sarah. Could you please send the link of your paper? Do you have a link of your?
Yeah, actually, this should I put it in the chat? So this actually presentation, yeah, this presentation has a paper link, and I'm gonna share it in the chat.
You could send it to all, no? In the chat if it's working.
I just need a minute to locate chat actually. This chat. Oh yeah, there it is. I can send it to everyone. So this is Joshua Bengio's paper for NBeats. I've shared it. Yeah.
Yes, you see. Thank you. No? And Ioannis Piros, he asked, Mrs. Farah, in Validé, do you use NBeats with transfer learning, or do you usually fall back to simpler models? For example, exponential smoothing, linear regression, random forest, etc.
What we do is actually it's even a lot more simpler than that. What we do is linguistic analysis. So we use NLP techniques for our work. We use sentiment analysis a lot, and we use customer profiling a lot. So we use RFM model, recency frequency monitoring model, and we use sentiment analysis model. And well, that's what works on social media mostly.
Okay, thank you. You are a founding member of Aspire in Pakistan, which is a non-profit formed by a network of overseas Pakistanis with a vision of socially and economically prosperous Pakistan through innovation entrepreneurship. That's what I read on your website. Who are these overseas? I mean, you are not overseas, no? So there must be some other overseas.
Yeah, so actually founding member, we have I think 3 to 5 founding members from Pakistan, based out of Pakistan. They're all over the world. We have great support from UK and Valley and in the US. And then in our meetings, it's surprising how people join from every corner of the world. Mostly they are who were in Pakistan. They moved out some years ago, and they think that Pakistan has the potential of entrepreneurship, so they're bringing back the learning, the exposure, and the funding.
Great. Is it difficult to start a new AI company in Pakistan?
Actually, there's a lot of support, and it's increasing because you see, Pakistan is a very populous country, and our median age of our population is 22. So plus for AI and technology-based startups. But if someone really wants to have a successful startup in Pakistan, then understanding the regulation is very important, just like in Europe. So yeah. we have very intricate legislation and regulations, which one needs to understand if they really want to monetize a technology startup.
And you are with Aspire, can I understand it, help these startups for the regulations to find money? Is that what you're doing?
Yeah, so I mostly train people on creating a product design and pitch, and also if there are people who want to work on technology and they're lost, and I guide them on supervise the technological aspects of their startup. And then we help in networking in everything that a new startup needs, because we're very open. We are also creating these competitions, and they're such inclusive competitions that now one of the competitions of Aspire has turned out to be the biggest competition of Pakistan. It's called NIV. So there's so much to do, and everyone is working voluntarily. So everything from training till connecting them with the investors and everything in the middle, it's done by the founding members.
Yes, and the investors are either from overseas or from Pakistan, or Where they, or from Silicon Valley, or?
So in my experience, even my own startup had its angel investor from Aspire. So the founding members themselves invest, and then we have venture capitalist networks, which are kind of a mix between, some like a venture capitalist firm where one of the founder is from Pakistan, but then some are in Valley and some are in Europe or Middle East. So it's always a mix, and local independent investors are still, not very big risk takers. I gather that because we're very new to entrepreneurship. We're moving from family businesses to entrepreneurship culture. So we don't have a lot of active standalone local investors, but we have venture capitalist firms and then people from everywhere who support Aspire and who believe that, the money will go in a more profitable startup.
Yes, thank you. And then I mean, I have so many naive questions. Are there many students interested in AI in Pakistan, or is it rather you still have to encourage students to study?
So I think ChatGPT, the advent of ChatGPT actually motivated a huge chunk, and then because our population is younger population mostly, so a huge chunk of people wanted to get the knowledge of AI because they could see its deployment possibilities. At the
Yes.
same time, a lot of people just wanted to leave it thinking that now our job is done. What are we doing here? So that was one point when there was a huge exit and huge entrance. Other than that, they're always very inquisitive and inquisitive professionals and students wanting to learn anything about AI, and because now everything is on cloud, so our deployment is standardized with the standards of clouds are global standards. So there's no restriction on what we can deploy or what we can do, and that is actually enabling a lot of people to work
Yes.
in AI.
Yes.
So in Pakistan, Pakistani startups and Pakistani projects, even our final year projects, are mostly around the software, not hardware based AI. Software based AI is getting very popular.
Yes. Yes. And basically, as we are living now globally, we can, as soon as you have in the cloud your software, you can find customers wherever.
Yeah.
Yeah. So this
exactly. So it's a borderless technology, and I think the trends are pretty much global.
Yeah. Yeah. There is this is my favorite question, and I'm doing since 4 years this Café. Now we're coming to the more save the world societal development goals from the UN. Are you also having ideas how to use basically AI not only for sales or for medical, but also is there ways of prevent hunger or climate change? Do you think there is a chance that AI could help to solve these complex social challenges?
That's a very difficult to answer question. At an operational level, anything that is generating data can use technology for better use of data for predictions. So at that level, operational level, world hunger and climate change can benefit from data analysis and AI. But it is not a machine's problem. I mean, machine is not hungry, and machine is not getting needs cooling, or it is affected by temperature as much as humans are. So in the end, the decision is still made by humans, and that is not automated. We made to believe that it's fully autonomous technology. It's not. There is a human in the loop, and that is where the responsibility is more than ever for us to decide where to use technology.
I think you can use the AI tools to analyze the data. For example, with climate change, you can predict, unfortunately, already all these climate changes. But yes, but it's right. It's up to us. And now that you are from Pakistan, and I have here in the Café from all around the world people, do you think there could be public-funded global AI research projects? Would that be interesting?
I think that is interesting, of course, because more people from diverse backgrounds add so much to the quality of the project and so much diversity which is needed. So obviously, But also, I think now we need global deployment of technology, and we can localize it for our own regions. But we should think about moving towards global policies, AI ethics, and global teams and global funding for doing something really worthwhile with what we have at hand.
Yes, I mean, often, I mean, you know that we are in Europe, we are very busy with our AI ethical and legal policies. We have an expert group and everywhere nationally and at the commission and so on and so on. So and that's, yeah, I mean, this is not in Europe, it's also in other places. So this alone is not so easy for a startup to understand all these legal policies. And you help also with Aspire that your startups or people you support, that they understand legal and ethical complications.
Yeah, like I just said, that someone who wants to invest in Pakistan needs to understand our regulations, and most of the foreigner co-founders, actually, that's where they fail. They couldn't understand the regulations, but it's also vice versa. Pakistan needs to understand where the globe is going with AI policies and ethics, and where it is going with the legalities surrounding technology, because it's changing very rapidly. And one struggle to penetrate in European market has been the policies. So I think we also need to have a governing body for global policy regulation. Otherwise, that might just alienate some parts of the globe with difficult to understand policies, because people would not be able to work there.
Especially small ones. I mean, startups. I mean, you would have to spend a lot of money on lawyers, no? And so it's good for lawyers. But
trusting that the last McKinsey report on AI technology and jobs showed that people like myself are actually in abundance. People who are doing Python code and deploying it are actually in abundance. But there is a dearth of policymakers in AI and lawyers in AI. So this is a good time to enter this field if someone has ever been interested, because we really need people who understand law around technology and ethics around using technology.
yes. Okay, is there any question anymore? I don't see it. My questions are all answered. Then I would say I don't see it. No. So then I thank you very much. This was a great cafe. I got very much inspired. I think your work is great, that you are having a company, but at the same time do this non-profit work of helping the Pakistan network to grow. So thank you for coming here, and for the audience, also great that you have been here, and we will have a recording, as you know. I will send it to you, Farah. You will check it, and if you give me green light, I will, as always, put it on YouTube on the channel AI Café, and it will be, like always, on the AI for Media website, our project website. And so thank you again, and have a nice day, and bye-bye.
Bye-bye.
Bye-bye.